Hello, everyone. My name is Asante Ntiro, and today I will be sharing my presentation on what is Web3. I think for the last 2-3 years, it's been a big thing, discussion on Web3. I've been seeing it a lot on the internet, on Twitter, on Facebook, where there's been a lot of discussion on what Web3 is. As we can see here in this graph from Google Trends, there's been a lot of increase in searching for what is Web3 over the past couple of years. It has decreased recently, but it has increased by almost 100% over the past 5 years. So, what is Web3? Usually, people describe it as the decentralized internet. So they'll say that it's user-owned and user-controlled. So what do we mean by decentralized? I'll start with a basic kind of way that we usually think of it. Let's look at topologies, network topologies. So on the left there, we have what is usually called a star topology. This one, there's one central, this one, which is highlighted with purple and the blue outside. So this is the central node, and then users can connect to this to access whatever resources are available from the central node. That's what a star topology is. And then here with the hub topology, you have these nodes that connect to central nodes, but there are many of them that connect to each of these nodes. And then we have, sorry, this one is supposed to be a mesh topology. I made a mistake. So in your mesh topology, all of the nodes are interconnected. Why is it good to have like a hub topology? Because your network will be more resilient. So for example, if this node fails, you can still have access to the other nodes through maybe some routing protocols or something like that. If you have a hub topology also, if this node fails, you can still access other parts of the network through routing. Not all of them will be accessible, but at least you won't lose all functionality. And then now in a star topology, unfortunately, if the central node fails, you won't have access to any of the infrastructure that you've had. So it fails completely. Now, an example of all of these would be like in a star topology. This is now what we call a centralized kind of system, where all the resources are in one place. An example of this, it would be, for example, maybe government issued identification. There is one central body, which is, for example, NIDA, and through NIDA is where you can be able to get all of your information. Your identification. But without the central node, which would be NIDA, you would not be able to get any of your information. In a hub topology, this is now more decentralized. So there's less coupling it's loosely coupled, meaning that, again, it's more resilient. If one node dies, the rest can be able to function. Like most of the internet works on actually in such a way. For example, Twitter can be connected with GitHub. You can link between the two, but if Twitter fails, you can still be able to use GitHub functionality and maybe another service as well. So one example of where star topology happened and it brought a big failure on the internet is in 2021 with the BGP protocol failure that happened at Facebook. We saw that Facebook, WhatsApp, and Instagram, all of them went down for a very long time. So that's an example of centralized topology, which is typically what Web 2 is made out of. Now, Web 3 is now in this paradigm where everything is decentralized or distributed. So you can have functionality that does not depend only on one node of the network. And this is, we're considering it the network layer. Although Web3 technology, and when we talk about decentralization in Web3, we're talking about the entire stack. Like when you think about the OSI model, we're talking from the network layer up to the application layer. So now this is how the web has been used, and it's different paradigms. There was Web 1.0, which was from 1990 onwards. Web 2.0, which was from 2005 onwards. This is the realm of social media and Facebook and all of that. And now we're in Web 0.3, which is from 2020 onwards. Now, when we say user role, what we mean is you as a user, what part do you play in Web 1, Web 2, and Web 3? In Web 1, you are only a consumer. You could not put your information on the website. You could only read static pages. Like you would go, it was like reading a phone book. You go to the website and you just read the information that was provided to you, and then it's over. That's your whole interaction. In Web 2.0, you're now a creator. You can make posts, you can give likes, you can update your status, you can upload a YouTube video. That's your sort of role in Web 2.0. And in Web 3.0, you can own your entire identity, meaning all of the things that you post, all of the things that you generate on the website, on the internet, belong to you. You can have like a private key that generates a public key that belongs to you, and it cannot be generated by anyone else. So it has a unique ID to whoever is associated with a certain account. Again, like we said, consuming, the content that was there on Web 1 was only linked and static, meaning you could link from one page to another, but there was no dynamic content. Web 2.0, like with social media, you're constantly interacting. We can get into more of the generative and repurposed stuff in Web 3.0. And the infrastructure as well. In Web 1.0, you had one mainframe somewhere that was hosting a website. And in Web 2.0, now we have trusted providers, which we're still using now. Like, for example, these cloud technologies where you host, because you trust AWS or you trust Google Cloud, you host your information on on their services, on their infrastructure. And then here on Web 3.0, there's trustless commons. This means that there is a linking of several computers that have inbuilt protocols that don't require you to trust them. There's things like the Byzantine algorithm and a lot of stuff that has to do with blockchain. Also with monetization, now you had e-commerce with eBay, with Web 1.0. Now with Web 2.0, us ourselves are the commodities, because your sold ads and your attention is what makes the real money. And with Web 3.0, we're seeing things like auctions and open markets, where people are able to sell their goods to each other because of the trustless ecosystem. Like, I think many people have heard about NFTs and the metaverse. All of this is happening on Web 3.0, and it's facilitated by open markets. So usually now typical architectures of Web 2.0 and Web 3.0. Here is a simple example of a Web 2.0 architecture of a web app. Here's you, the user. You go into your browser. Your browser connects to the internet and interfaces with the web server. The web server provides the front end, which communicates with the back end, which in turn communicates with the database. And then you're able to do all of your interactions. On Web 3.0, the architecture is a bit different. Sure, you have your web server that gives you the front end, but now the back end is a bit different, very different. You have some things called smart contracts. Okay, also this is an example specific to Ethereum, the blockchain Ethereum. So you have what are called smart contracts. These are what do the backend logic for your web app that interface with the Ethereum virtual machine, which now behaves like one machine, but it's an abstraction of one machine, but essentially it's several nodes communicating together to do the backend logic that you require for your program. So that abstraction is what interacts now with the blockchain, which is a bit beyond the scope of this presentation. Next. Oh, my computer is frozen. Okay. So a big problem with Web 2.0, if you've been following a bit of the conversation, is that the Web 2.0 companies are selling our data. Every time you log into Facebook and you like a post, the time that you spend on Instagram as you scroll, all of that is valuable data. And these companies are aggregating that data and selling it at a profit, and not giving any of us the benefits of that data. So as you see, Drake himself doesn't like Web 2.0, but Web 3.0 is changing that paradigm and making us ourselves, the users, to be able to own our own data, to own our own interactions on the internet through different protocols. Also, the move to Web 3.0 is not just, let's say, aesthetic. It's not just a cool thing to do. As people are increasing and functionality is increasing on the web, like with things like Internet of Things and self-driving cars, there's a lot of data being produced at a very exponential rate. So we cannot continue to do all computation on like a central mainframe. We need a distributed network of compute and storage. so that we can do things like edge computing, and so that we can decrease latency with things for like artificial intelligence, all of these things, because there's so much data being produced, and over time it's going to like it's going to be very expensive to host your own websites on and web apps on one server somewhere. So that's why we need things like Web3 technologies and distributed systems. So here is an example of that. As we're scaling, as we're increasing users, usually on the web, this is what we'd like it to be. We'd like increased throughput as compute. I mean, so that as there are multiple threads of computation. That's what parallelization means. So this is what we'd prefer, but that's not the case. According to Amdahl's law, very smart computer scientist, this is generally what happens. But in truth, it's even worse. It's even less efficient, because like with big databases, sometimes you can have incoherence in the data. One source is saying something different, and another source is saying something different. We have things with consistency. The data is being reported as a different value by one agent than it is by another. So these are things that happen with these big databases. So that's a big issue with the current mode of the web technology that we're using. But with Web3, because as you're adding more users, they're also strengthening the system. They're adding more compute, they're adding more storage as well. For one very good example is with torrents. I think I've heard of people downloading movies illegally. I'm not one of them. I just hear people doing that. But as when you torrent things from whatever site that you're using, the more users that are torrenting that or downloading that file, the better the quality of the download, the faster you can download. So there's that cooperative advantage. The more the users, the better the service. There's also something else called IPFS, which is a distributed file system. That's where most of these decentralized apps, the front ends are hosted. It's as more users increase, the better the throughput and the better output for your decentralized app. These are some cool things to look at, and that's the end of my presentation.